Everyone knows the Sahara as the place where things vanish. Caravans, explorers, empires. But hidden in the northwest corner of that desert, something moves that should not exist. A train stretching nearly 2 miles long, hauling more than 20,000 tons of iron ore across one of the harshest landscapes on Earth, with no city at the start and almost nothing at the end. It runs without tourists, without fanfare, and without a place in the global imagination it has clearly earned. If this is one of the heaviest trains ever operated on the planet, how has it remained almost completely invisible to the world? The answer reveals something uncomfortable about which engineering achievements we choose to celebrate, and which ones we are content to let the desert swallow whole. The Iron Ore Company of Mauritania, known as SNIM, operates what is by weight one of the most formidable freight operations on Earth. The line runs 704 kilometers from the iron ore deposits of Zou, deep in the Saharan interior, to the port of Nouadhibou on the Atlantic coast. There are no parallel roads for most of that distance, no towns along the route worth naming on most maps, no infrastructure safety net if something fails in the middle. Just iron rail, iron ore, and iron heat. The trains that run this corridor carry between 84 and 210 cars per consist, loaded with raw or excavated from some of the richest iron deposits in Africa. Gross trailing weights routinely exceed 20,000 tons. Some documented runs have approached 22,500 tons of total load, figures that place the Mauritania train in direct comparison with the heaviest freight operations ever recorded anywhere in the world. This is not a marginal or regional curiosity. By the standard of raw tonnage per movement, this is a machine operating at a scale that demands serious engineering attention, yet it receives almost none. The ore deposits that created this railway were identified in the 1950s. A joint venture between the Mauritanian state and international mining interests, the line was constructed between 1960 and 1963, pushed through terrain that resisted every modern convenience. Engineers drilling surveys into the Saharan rock found sand drifts that could bury equipment overnight, temperature swings that cracked steel on a seasonal cycle, and a total absence of the logistical infrastructure that makes large-scale rail construction manageable. There were no nearby ports for unloading construction materials, no established labor markets, no maintenance depots within hundreds of kilometers. The line was built anyway, not because it was easy, because the ore was there, and getting it out required either a railway or abandoning one of the most significant mineral discoveries in West African history. The decision to build was not a triumph of ambition in the abstract. It was a calculation made in the language of necessity, the same language that has always produced the most honest engineering in the world. To understand what makes the Mauritania train extraordinary, the numbers must be read carefully and in full. A typical loaded consist begins at Zouarate, with between 200 and 210 hoppers, each carrying approximately 84 metric tons of iron ore. The total payload approaches 17,000 metric tons of ore alone, with gross train weight including locomotives, cars, and equipment pushing past 22,000 metric tons on the most demanding runs. The motive power to pull this weight across 704 kilometers of desert track has evolved over the decades. Current operations rely primarily on diesel-electric locomotives, often running as multiple units lashed together, producing combined outputs in the range of 10,000 to 13,000 horsepower for the heaviest. The track itself was engineered to accommodate axle loads that would be considered aggressive by the standards of most national railway networks. The ruling grades are modest by mountain railway standards, averaging around 3.5 per thousand on the main alignment, but the sheer sustained distance and the relentless desert conditions impose a cumulative mechanical burden that no test track can simulate. Heat warps rails. Sand infiltrates every lubricated surface. Thermal cycling works metal fatigue into joints and fasteners year after year without mercy. The maintenance mathematics behind keeping this line operational are not glamorous. They are relentless. The journey from Zouarate to Nouadhibou takes between 12 and 20 hours, depending on consist weight, track condition, and operational factors. That figure alone contains a story. There is no quick run, no express configuration, no shortcut through the desert. Every kilometer is earned by the locomotives pulling against a load that, distributed across the train's length of nearly 3 kilometers, creates dynamics that require careful management to prevent in-train forces from buckling or breaking couplings. The crews who operate these trains understand that a brake application at the front of a 200-car must be carefully timed to prevent the rear third of the train from running into the front two-thirds under the momentum of 20,000 tons of iron. This is not a theoretical concern. It is the daily operational reality of running a train whose physics operate at a scale that imprecision. The engineering required to manage longitudinal train forces at this tonnage, at Saharan temperatures, on track that cannot be replaced overnight, is of a caliber that would merit serious study in any industrial context. In Mauritania, it merits almost no coverage at all. The port at Nouadhibou was built specifically to receive and ship this ore. The terminal includes ore stockpiles visible from satellite imagery, a shiploading facility capable of processing the entire contents of a long train within hours, and mooring infrastructure for the bulk carriers that carry the ore to steel mills in Europe and Asia. The flow is continuous. Trains arrive, unload, and return to Zouérate empty. The loaded return journey is approximately 450 tons of empty rolling stock, moving at higher speed, often completing the circuit in under 15 hours. The cycle then repeats. SNIM has operated this loop for over 60 years. The ore has never stopped moving. Iron from this desert has ended up in steel products across 3 continents. The supply chain that begins at Zouérate and ends in a mill in Germany or South Korea passes through one of the least documented heavy freight operations on the planet. There is something almost deliberate in the way the world has chosen not to look. The political and economic history of the line carries its own weight. Mauritania is one of the poorest countries on earth by measured GDP. The SNIM railway represents a significant fraction of the nation's export earnings. When ore prices fall, the country feels it. When the locomotives need major overhauls, the parts must be sourced internationally, often with lead times that no railway in a wealthy country would tolerate. In 2006, a major derailment near the Moroccan border sent shockwaves through the operating budget and briefly halted ore exports. Internal engineering reports from that period, reviewed by rail industry analysts, cited accelerated track degradation from heavy axle loads, combined with the thermal expansion dynamics of rail laid across sand substrate in extreme heat. The solutions applied